Hi, thanks for coming. Uh, so I'm going to be talking about FreeBSD, the operating system. And if you know, FreeBSD is really old. So I'm trying to go through this 20 years or 25 years of things that happened. So I'm mostly just going to be talking about things that I care about, which is probably not what you care about most. So if you have more questions about things that I don't cover, just catch me like after the talk or in the hallway. Yeah, and I will try my best to explain. So, who am I? I like to know what happens in my computer. So you write software, and then you have all these nice things that gives you graphics or text or whatever. I like to know what happens underneath the system call layer. So what actually takes this hardware. So I switched to my personal infrastructure to run on FreeBSD quite a while ago, then started experimenting more with it, and then I really liked the system and then started hacking on it. And also, I should mention this, in its true sense to the BSD license, this presentation is written by multiple people, so I'm borrowing a lot from other FreeBSD contributors. What is FreeBSD? FreeBSD is a complete operating system, as opposed to you get your kernel from somewhere, you get your libc from somewhere, and then you stitch all of them together to make an operating system. We don't do that. We manage the kernel, the device drivers, the user land things that you get on top of it. We manage all of them together. You also get really nice tools. We have a good compiler from this decade, and tools like jails, capsicum. I will mention all of this, like what they mean in a bit. Also, when you install a FreeBSD system, the moment you finish installation, you have all the tools to start writing your C code. But most of the times, that's not what you want. You may want to write to use your any editor that's not VI or VM. So you can go and install them from the multiple packages that we maintain. And FreeBSD also comes with really good documentation. We have a FreeBSD handbook, which is 90% of the time, it contains all you need to run a system. Well, the 10% varies. And all of this is developed under an open license by an open community. So who uses FreeBSD? I'm sure some names are more familiar than others. NetApp, Dell, and Kansas, all these people use FreeBSD for their storage needs. Then there is Apple. So most of the user land code on OS X, Mac OS now, and their iOS systems come from FreeBSD. Then there are networking people like Juniper, and other vendors who basically take FreeBSD and use their fork to run most of the internet. Then WhatsApp, I'm sure that's a familiar name. Their entire infrastructure is built up on FreeBSD. They actually push the limits in which a traditional, like what you expect from a traditional machine doing networking things. As in, they're the first ones to do 10 billion connections on a box using FreeBSD. And an interesting name is Sony. The PS4 actually runs FreeBSD. And PS3 also ran FreeBSD, but they never publicly acknowledged it. At some point, while they were developing PS4, there was a lot of interesting questions on the mailing list where the community went back and asked, like, you're asking very particular set of questions. Are you using FreeBSD? Then they admitted that PS4 runs on FreeBSD. Most of the Yahoo runs on FreeBSD. Well, Yahoo does not really exist anymore. So why use FreeBSD? We have really nice tooling. When you install FreeBSD, you get a compiler and libc that work well with your kernel. So if you have done any embedded development, you know that you get a tree, you try to recompile it for a hardware, then you realize that all your tooling expects some particular minor versions of your libc, or your debugger does not understand your APIs because they were changed. So we don't have all of any of those problems. Our tools are, when you get a certain version of a tree, all our tools work together, and they work together well. So talking more about tools, we have a really nice, or we always used to have a really nice lightweight virtualization system. They're jails. Then we have a really new privilege separation mechanism, which helps you protect your computer way better. That's called capsicum. And recently, we imported a lot of nice things from Solaris. So we have first-class support for ZFS and dtrace. Dtrace is a debugging tool. So if you want to know what happens in your computer, say my program is doing something, how do I know? Dtrace, you run dtrace, and it can tell you what exactly it does without having much of a performance penalty. So it's really, really maybe 100 times faster than just running strace, and it gives you really a lot of output. Like strace also only gives you system calls. Dtrace can tell you what userland calls are being made. We have a mature release model, meaning at every 6 months we release, but it goes through proper release engineering checks. There is a code freeze, and then we make sure there are no bugs that might make your computer explode, and only then we release it. And again, the handbook is really good, and they are translated. And I didn't check if there is a Czech version of it, but if not, you should work on it. The reason there is a Chinese link here is because so when one of our community members, GNN, was giving this talk in China, and apparently there is really the Chinese version of handbook is really well translated, and they use it a lot. So all of this code is under the BSD license, and if you have a problem, so the BSD licenses basically use our code. We would really like you to use our code, but please don't sue us. So as long as you like it, just send us patches. We would be really happy to merge them. So what do I mean by a whole system? So when you get a version of FreeBSD, all of these things that I mentioned before are developed together, and they're developed coherently so that at some point you realize that your Firefox doesn't work because a minor version of the kernel changed how shared memory works. That's not going to happen because people who maintain your kernel are who maintain your most of the userland. So what's new in FreeBSD 11? I should mention that FreeBSD 12 is coming out in 2 months. We are going through freezes now, which is this stage where we make sure there are no breaking changes, and it's a major revision. So we are at 11.2 now, and all the minor versions, 11.1 and 11.2, we make sure that we don't break any APIs, but for a major release, we can. But this is about 11, so the new things happened in 11. We got a really shiny new package manager. Package, go figure. Well, it's really nice because it gives you flexibility when you need it. Maybe you want to recompile your application to your minor CPU version because it gives you a huge performance bump. But it used to be that if you do that, then it gets out of the package tree. Then you do a make install, and your operating system doesn't know where this is installed, and you have no way of updating it. But with package, you can actually quite easily integrate that into your workflow, and package would just say, oh, it's a different version of an upgraded package. We have binary system updates in 11. What it means is when you're updating your kernel, you don't download the entire kernel. You don't have to go through and get like this 200 MB blob or whatever. You get the binary diffs of the things that you changed, and you just apply the diff. And so when you're updating in the field, maybe an embedded system which doesn't have much network, and you're updating over GPRs or whatever, you can do this. Yeah, more things. Faster, bigger, better. File systems. So we got some file systems, well, set of us from Sun, since Solaris is not being developed anymore. Most of the Sun developers have either moved on to Illumos or FreeBSD, so we have first-class support for it. Cephas is a file system and also a volume manager, meaning if you have way too much data and at some point you realize that, oh, gee, I can't fit all of my data in this disk. So you can just buy more disks and throw at Cephas, and Cephas will happily make your file system bigger. And it's also designed in a way that, so none of the other file systems expect disks to lie. But Cephas makes sure that if your disk is lying, as in they have a bad block, but you wrote some data, and it would tell you that, well, I've written it, but it's not actually there. Most of the other file system will just go on their merry way until the moment you try to read it back, and then, oh no. But Cephas will actually make sure that it's there by forming a checksum, and then you check, and it'll automatically tell you, oh, this is not working out well. We also have UFS. Well, we have a really good file system layer, so you can actually put any file system on top of it. But UFS was the original file system, and it just keeps, it's a native FreeBSD file system. It keeps improving. At some point, it gained support to do snapshots, which are copies of your file system at a specific time, but you don't spend any more space on it because the only thing that's saved are the things that changes. Say you snapshot your file system on Monday, and then you change your file A to do something on Tuesday. The only space that you would spend extra is the changes in A. So, and you can roll back quite easily. So if you do a system update and you realize that it's not going well, you can just say, oh, go back to the point where it was on Monday, and we'll just go back quite fast. Jails. So jails were one of the coolest features of FreeBSD as far as I'm concerned. I use them quite a lot. So it started as a project to figure out what happens when you have root on the system. So root can basically do anything, which means it can just go and destroy a system if it wants. So to contain it, so the idea was to contain root to a specific set of resources, and they have complete reign over them, but they can't do anything outside. So jails get their own separate file system namespace. They get their own network. They get their own file descriptors. So basically, you're contained in that system. And say if you're using jails to run, so you can use jails to run your services, and you run your PHP web application in jails, and somebody managed to get out of it, but then they would find themselves in a more secure environment, and they can't really do any physical harm to your physical box because they're contained in the jail. FreeBSD network stack. So when BSD 4.3, 4.4, which was the basis of the start of FreeBSD project. No, not 4.4. So BSD was the reference implementation of TCP/IP. And then we had the stack for a really long time. Almost all embedded systems or other operating systems just basically use BSD network stack at this point. And the FreeBSD project keeps on improving that. The IPv6 support, the CAME project, FreeBSD, the CAME project which implemented IPv6, the FreeBSD was also one of the first platforms which got it. We have 3 firewalls. because reasons. IPv4 was the native FreeBSD firewall. It works, it's well documented. At some point, we gained support for PF, which is a firewall from OpenBSD. And if you really like very descriptive way of writing your firewalls, you should have a look at PF. More networking stuff. At some point, we got support for vMage, which is a virtual networking layer. It essentially means you to do, allows you to do a lot more stuff with network. If you want, say, multiple routing tables, you can do that with VNet. For example, say, you have an application and you don't trust it, and you want it to go through a VPN link always. In that case, you can just create a VNet routing table and put it in so that the application only sees one interface, which is your VPN interface. And if somebody breaks out of that application, they really can't do any network over your regular paths because the application has no access to it. So you can also combine that with jails, where each jail has their own net layer. So if you don't believe in physical machines anymore and you run a hypervisor, we have images for almost all the regular suspects. You can just download and use them. At some point, we also started implementing our own hypervisor. This is very similar to KVM on Linux. One of the things that happened in 11 is we ported, it's called Beehive, and OS X took it. They call it Xhive. It runs Docker on OS X now, if I'm not mistaken. They just booted Linux binary on it and then use that as their Docker implementation. Capsicum. So Capsicum is one of the research projects that got implemented in FreeBSD. So when you have a process, it has permissions, but how do you granularly define these permissions? Capsicum calls them privileges. And the idea is that you have a set of privileges when your process comes up, and it can only shrink. So say that one of the privileges is reading a file descriptor. At some point, the process can say that I don't want this anymore because I don't care about writing to file. But as soon as they drop it, they cannot get it back. A good example is containing problems with TCP dump. So TCP dump has, simplifying a bit, TCP dump would have a parser which looks at your packets and parses them, and then something that writes these packets to disk. The parser part does not need access to your file descriptor, or does not need any other access than access to a specific memory region. So as soon as that packet parser comes up, it drops privileges so that it can only see these things. And if, there was a certain exploit which basically makes you craft a specific IP packet so that this parser would explode and give you root on the system. But with Capsicum, this wouldn't happen, because as soon as this process explodes and it tries to access things that it doesn't have privileges to, the OS would just kill it. So it's a really nice way to contain security issues. We also have a Linux emulator. Linux rarely break ABI anymore. So what this does is you get a Linux binary because of some reason, and mostly proprietary software, and maybe you lost the source code to it, and you want to run it on FreeBSD. You just run it, and the kernel would figure out that it's a Linux binary by looking at the headers, and it would just start translating system calls to the Linux system calls to FreeBSD system calls. One of the things that, this is heavily used. So this was originally implemented as a way to run Doom on FreeBSD. So, but people have successes of running the Oracle database and other CAD things. More things from 11x. I don't have much time, so I'll just skip it. it's better. So how do you join the FreeBSD community? So you join the mailing list, start using FreeBSD. You can get the code from either our SVN or GitHub. You might encounter problems. If you encounter problems, please fix them and send us patches. And if you send enough patches, somebody would notice and ask core that you should probably be allowed to commit because they've been sending us way too many patches. And if core agrees, you'd get your commit bit, and your mentor, the guy who proposes you to core, would help you commit a bit more, and then you'd be sent on your own merry way, and then you go find another mentee. So how do you learn more about FreeBSD? We have a website. We have mailing list, forums, and handbook. Just type it into your favorite search engine, and that's about it. Thank you. Questions? Yes.
What is the relationship between TrueOS and FreeBSD? If anybody didn't hear that, what is the relationship between TrueOS or TrueOS and FreeBSD?
TrueOS is, in FreeBSD world, you can't really call the distribution, but it's mostly they take the FreeBSD code, they make sure that it boots very well on a desktop or a laptop, and the community has a lot of intersections. Is that what you're looking for? I mean, it's a desktop oriented distribution of FreeBSD. They do a lot of work, and a lot of it gets back to upstream if it concerns FreeBSD. So we like each other.
I get the impression it's sort of the official desktop version. Is that not really?
Installing FreeBSD on a desktop can be a bit pain, but TrueOS make sure that, because most of the people who install FreeBSD does not really care about X because, some people don't use X on their machines. But TrueOS makes sure that you get Valent now, and you get a proper desktop environment to start with. So yeah, it's geared towards that kind of communities. They complement each other, I would say.
Thank you.
All right.
I would like to ask you, what is the difference between FreeBSD and OpenBSD? What's the difference there?
I'm not an expert on OpenBSD, but so the OpenBSD focuses. Well, I can only give you the outline of an answer. OpenBSD focuses more on security, as in they are really, really concerned about security to the point where, at some point they deleted their Bluetooth stack because nobody was maintaining it. And it made sense because their audiences care more about having secure code than, maybe running that in a high performance environment or having more features. So FreeBSD strives to be, FreeBSD would like it to run faster. So there are philosophical differences, but we like each other. We do get share code. If something's really nice in OpenBSD, we imported it or tree, or OpenBSD imports FreeBSD code. 2, is that the answer you're looking for? Yes.
I wanted to ask about the BSD license. Do you think that FreeBSD gains or loses because of its license? For example, that Sony or other companies like it don't submit changes back to the FreeBSD.
Well, this is my personal opinion. I like my BSD license because I really don't like to litigate. I'm an engineer. I like writing code. I don't want to work on code cases. So here's my code. It might explode. And I would like you to use it, but don't sue me. So that's my philosophy, and BSD license aligns very well. Whether it helps FreeBSD or, yeah, I would say it helps because it, multiple reasons. One being that we don't really have to care about all these things. Yeah.
Thank you.
Any other questions? All right. Thanks for coming.